Good afternoon, everyone. We're going to give it just a minute or two here. People are still logging in and getting confirmed. Thank you very much for taking the time out of your afternoon to join us here for our webinar on the facts about Aramid fibers. Like I said, we'll get going here in about a minute or two, just giving everybody kind of another minute or so to get logged in. All right, good afternoon, everyone. My name is Brett Stanton. I'm the Executive Director of the Asphalt Pavement Association of Michigan. And I want to thank you all for taking time out of your schedule to join us today for a webinar series. Today's topic is the facts about Aramid fibers. So the concept of Aramid fibers, the use of Aramid fibers is really not a new idea. However, with supply chain issues and cost fluctuating, it's definitely seen a resurgence of use, and we wanted to have a webinar here to all of us to learn more about it. Today's topic, like I said, is Aramid fibers, but hopefully at the end of the day, you'll leave here with a better understanding of how the fibers work, because there are different manufacturers out there, the benefits of the fibers, for the plant folks, how to incorporate those into the mixture. I think for everybody involved, the cost associated with using fibers, when, where, how, why somebody should consider the use of fibers, and then finally some valuable lessons learned from the field. So we have a great speaker with us here today, and I'll ask that he advance the slide for us. All right, so Microsoft Teams. So hopefully, I don't know how familiar you are with Teams, but everybody has had a crash course in virtual learning over the past few years since the pandemic. But the opportunity here to answer and ask questions will be in play here. So feel free to raise your hand or use the chat function. I will be moderating the session, and we'll either ask your question via the chat, or I can unmute you if you want to ask the question yourself. And then if you have any trouble with any of this stuff, you can always, either just try to kill the application and then log back in by clicking the link that you were given, or feel free to shoot me an email, and we will try to do our best on the technical side from here. This presentation is recorded, so if you want to copy to view yourself, or you have a colleague or somebody else you think would benefit from this information, feel free to reach out and let me know, and I'll make sure I get you a link. So, next slide, Phil. All right, professional development hours. So as charged here, we will be issuing PDHs, or professional development hours, for anybody in need. If you don't have a professional degree in which you need to keep track of the hours, then feel free to disregard. But we'll be sending those out. We ask that you stay logged in for no less than 85% of the event in order for us to honestly be able to give you an hour's worth of time for your efforts spent here today. So with that, I will get going on introducing today's speaker. So today we have Phil Blankenship from Blankenship Asphalt Tech and Training, and he was kind enough to share a bio. I told him that I wasn't going to read the entire bio. He's got a long storied history, so I will try to summarize so we can get forward at the topic at hand here. So Phil graduated with both a master's, a bachelor's and a master's degree from the University of Kentucky. And there, Phil worked on the Strategic Highway Research Program, developing end design with Superpave Gyratory Compactor. After that, Phil became the Superpave coordinator and managed the asphalt binder laboratory for the Kentucky Transportation Cabinet. A few years after that, Phil ended up joining Koch Pavement Solutions. He was one of Koch's project development engineers for new asphalt technology, and specifically was involved with the Strata product, which is an interlayer reflective crack relief system. So he knows a bit about cracking here, and I'm sure he'll talk about cracking during his conversation with you all here today. In 2007, Phil joined the Asphalt Institute as a senior research engineer. There, Phil managed AI's mixture and performance testing laboratory and coordinated the mixed design technology course along with other lab courses and webinars. And then in 2017, Phil took the leap of faith and started Blankenship Asphalt Tech and Training, a consulting engineering company that uses his and his employees' agency, industry, and association experience to consult as well as perform asphalt binder and mixture performance testing. Phil is also a member of the Transportation Research Board Binder Committee and also serves as the executive board for the Association of Asphalt Paving Technologists, or AAPT, which is a fine organization. If you are not a member, I strongly encourage you to fill out the application and join. It's a great organization. Finally, Phil is also one of the chairs of the ASTM subcommittee D0426 on the fundamental mechanistic testing. So with that, I will turn it over to our presenter, Phil, who will be giving today's talk. And like I said, feel free to use the chat function, send me an email, send me a text, whatever, if you have questions, and then we'll hold those to the end. And then if you desire to ask those in person, feel free to let me know and I will unmute you and you can go ahead and ask. So with that, Phil, thank you again for being willing to speak with our audience today. I will turn it over to you and turn my camera off and mute myself. If you need me, let me know. Thanks, Phil.
Okay. Make sure all of this is working here, and think I've got this going. So
yep, good on my end.
Is my video showing? I don't know if it's showing or not.
It is. Yep, I see you.
Awesome. Long as it's working. And am I in the, because I can't really see anything on my end, Brett, is it showing up like in a lower right-hand corner or?
Yes, yep, yeah. Lower right corner for me, I guess it'd be the left hand if you were standing in front of the screen, so.
Okay. Little mini Phil, that'll work out fine then. Okay, folks, I'm glad that you all are with us today. Brett, thank you for the introduction. Fun way of saying, as you get a longer bio, all it means is my beard's turning gray. and I'm just getting older, right? I saw several folks on that I know, so always glad to see folks like that. Tim Ashenbrenner, it's been a while, so look forward to catching up with you at some winter meetings. And thank you for joining us from FHWA and everybody that's out there today. Thought it would be fun when I was asked to do this. I was approached by Brett and the guys. Of course, I've worked with Surface Tech for quite a long time. They're a long client, so some transparency there. But that also means that I've worked with Aramid Fiber since about 2015, 2016. I've had it in my hands working with it in the laboratory in some way. And when Brett asked me to do this, I thought, well, this would be good. It's when a product that you test in a laboratory turns into something that becomes of great interest. Again, today we just want to look at, why do you need to modify? What is Aramid Fiber? How to bid and build with it? We're going to look at the mix design process, then talk about it at the plant. We'll then go into a field with some case studies. And then actually, I won't have time today to really get into all the details and the testing with the Ideal CT and Hamburg Wool Tracker. However, I'll put those into the case studies, and that way we can just look at a glance of those today. So why do we want to modify the mix today? Well, when we get into with what we've currently done through past years, and I guess I'm going to back up one slide. When we get into it in the past years and we look at when I first came in industry, modified asphalt was still under question. Do we even need to be using polymer modified? And this was in the 90s. Polymer modified was really introduced strongly in the late 80s because everything that we did was just asphalt and rocks. And sometimes we get a little stubborn and a little sense of pride that we don't want to try anything new because we can make this work. Well, I don't know why we get bent out of shape on that. Why don't we want to try different modifiers? And yes, they'll drive the cost up. And sometimes we fight of, is it going to help it last another 2 or another 3 years or number 4? What about if we can make something last 10 years longer? What about if we can make it last 20 years longer? I know we have to worry, look at the skid and we have to understand profiling of the surface to make sure it's smooth. But what about if we can make things last a lot longer? You begin to pull out the stops, and then we understand the challenges that we face on, well, then we're not paving, we're fixing these roads, keeping up with condition, but we can't make the dollar stretch these other roads. So we have a tendency in today's world to make it thinner, 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 thinner. And now we have roads that may not last as long, but they're at least lasting 7 years, and we're spreading it out everywhere. So engineers face that all the time on how good do we want to make it and how long we make it last. But at the same time, we got to make sure and spread those dollars out so that all the road systems are in decent condition and you don't have just great roads in one spot and poor roads in another. Well, modification helps us to meet those challenges today, whether it's modified asphalt with the traditional polymer sense, other products I was just talking about with Brett early on that's coming out that's new. There's a lot of things being introduced to the market today. Other products you have today, little things called bio oils. Bio oils are just a neat product that's out that help us soften the asphalt. But the one we're talking about today is we're going to talk about a lot with the fiber. So why do this? Well, if you look at the rural interstate system, and this is updated as much as I can update it because they run about 3 to 4 years behind on these statistics. But since 1970, our rural daily traffic, and that's the bottom bar, has been increasing up until the 9/11 event. And now we see traffic begin to die off. Now, I bet you once we hit the COVID year, Brett, we're going to see that line take a big dive because of the work at home. However, the challenge, and again, this is on our rural, because if you're in a city, a metropolitan area, and cities such as Nashville, Atlanta, Detroit, New York City, and all those, you're going, I can tell you there's still plenty of traffic out there, and there is. But the rural interstate system, if you look at the average load, it continues to climb and has been climbing since 1970. In the 90s, or the late 80s, we added more weight. We allowed trucks to go up to 80,000 pounds, and then we allowed them to go on up on certain routes up to 120 1,000 pounds. Michigan even does higher than that. And as we continue to climb, we continue to move right on up into the approaching the 800% increase since 1970. That is a real challenge that's laid out before us. And especially when engineers are out there thinking, hey, if I design for 20% growth, I'm doing pretty good. 1970, you're looking at nearly 750% growth. Well, in today's world, I've got to modify to meet these things called balanced mix design. Today, you're seeing these diagrams put out with cracking on one side of the graph and rutting on the other. I call it performance engineered mix. I call it a performance testing. The term that's caught on is balanced mix design, where we balance the rutting with the cracking. And in that process, we use a mix performance test on condition samples to address different modes of distresses: cracking, aging, traffic, rutting, climate, all those different things, to put all that into a package to make sure that we can make a pavement last long. Now, this is just an example of taking a Kentucky mix that I worked with. And in this mixture, we simply added asphalt. We were at 5.4. Now the state of Kentucky's more near 6% on their mixtures. But back in the time, about 10 years ago, we would just add asphalt to the mixture. You can see I added on this one 0.5%. And my APA device at the time and my beam fatigue I'm running, the needle never moved on that mixture. However, it became more compactable, which that's another story, that as we improve density in the field, we also extend pavement life. This is just looking simply at putting asphalt in a mixture. Then we found out if I continue to add more, it did exactly as I thought. My cracking would greatly increase, the top right corner, and my rutting would begin to go down. Now, you may look at that and say, oh my goodness, my mixture is going to rut. Folks, our mixtures are so rut resistant today. Moving the needle on that APA or Hamburg, I strongly encourage you to see, and I guess I would say, how low can you go? Put some test sections out there, because we have way over designed on rutting for most of our mixtures that I'm seeing today. We have a lot of room. And that was on a mixture, again, where I added up to 1% of asphalt to get that needle to even move. Well, balanced mix design, if I look at it in this sense, and if I look at this plan here, okay, this sort of looks like what's going on here. This is the identical way, but on mine that I backed up, these two curves that are separated here didn't really separate on mine. Now, if I took them way out to the left, you would see that change a little bit. But here, the concept, and it's been out a very long time, and actually some of this work, some of these processes were not just invented. These concepts have been out for quite a long time. Asphalt Institute published things like this a long time ago, and NCAD and others. That if I look to the left, or the low area of my asphalt content, I have a mixture that's very stable but not durable. Go to the very far right, and I add a lot of asphalt. I have a mixture that's really durable but is unstable, or could push. So to get where I want to go, and I'm going to back up now, back on this slide, if I wanted to move over in this area to really increase my durability, I can't just add asphalt. Same thing here. I can't just add asphalt. I have got to open up my mixture to be able to allow it to accept more asphalt. So I've got to change the structure of my aggregates. Some cases that means washing the aggregates. Some cases that means a different size aggregate. And states right now, different contractors are exploring different options that can be looking at modification of the asphalt, modification of the mixture, and all of the above. That's where That's where the fiber comes in. So why do we move back and forth from rutting and cracking? Well, if I were to open this up to a discussion, the comments that I would hear that would be mentioned right now would be, hey, I remember in the 80s when we had rutting, and I remember the guys talking to me before that they had a problem with cracking, and we caused this problem. Well, and now here we are today talking about cracking again, and we just have a pendulum that goes back and forth, and give it 20 years and we're going to be dealing with rutting again. I don't think so. Yes, on where we've been, but now that we have these performance tests in place, Ideal CT, SCB, DCT, pick your poison on cracking, Hamburg, APA, flow number on rutting, Ideal RT, the hot IDT, whatever you may have. We have tools today that we didn't have 20 years ago. That we did have them on a research level and in the laboratories, the bigger labs, but we didn't have these at a contractor level and a state level. And now we can measure rutting and cracking real time on the mix design process and in the field. And as we continue to move into that, we're going to avoid getting into the rutting area while we continue to maximize our cracking. We have new glasses, if you want to think of it that way, that we just didn't have back then. So again, balanced mix design, trying to balance the rutting and the cracking component. I like to think of it not just balancing. Balancing infers, again, just asphalt. I like to think about taking this mixture that we've got and even making it better. Not just a balancing act, but improving on what we're doing. Tim Aschenbrenner, since you're on, I will mention this one too. For the states that can, and Michigan and the areas, whether in the U.S. or just in Michigan, where you can find those pockets of aggregate that work well with SMA, you'll find out that you will not beat the rutting and cracking resistance of an SMA mixture. If you haven't looked into it, look at the federal Highways Everyday Counts initiative and their TOPS program on encouraging the use of these higher performing mixtures. So again, mix modifiers allow us to use local asphalt and local aggregates and make performance improvements at the plant. And then we can use a Hamburg wheel tracker and an Ideal CT simply to allow the verification at the plant. I recently got into a design where I was doing an interlayer type of design for a contractor in a nearby state, and he was struggling to find the right aggregates over what the state had specified. This was sort of an experimental mix. He was having to bring things in out of another state, and you can imagine when you bring asphalt in and aggregates in from another area, the expense that you get into in trying to bring those products in, because now you're dealing with diesel cost, freight cost, on and on and on. And also, if you're dealing with asphalt, you're dealing with the timing there of making sure that you have to heat it up, of course, to get it back off the tanker. So all of these factors play in on where that you're going to deliver your freight or deliver your materials and the costs that go into that. So keeping them local and being able to improve what we have locally is really, really important. A lot of the proof is in the testing. This was a little work that we did when I was working on an interlayer and also working on the fiber reinforced mix. We'll show you where the fiber is in a moment. But if I go and look and I just take a regular dense grade and I'm looking simply at ASTM D8225, and I go and I put, if I take a dense grade material that let's say I would have here in Kentucky or edge of Ohio or Indiana, let's say I get a 91, and that's testing at 25C, all the normal parameters. Now I go and I put fiber in it. Now, again, this is not a repeated loading test, so I'm not really engaging these fibers except just one time, okay? So I'm just trying to pull it apart in an Ideal CT, a very simplistic index test. But it works to give us an indicator of what's going to happen. I can raise my Ideal CT value, and then I put in more, and I raise it even more. Now, what happens if I redesign that mixture into an interlayer, okay? I can redesign that into an interlayer and take that number with the fiber up to 650. Now I'm going to show you something, and I want to make sure, and if this doesn't come through on the screen, Brett, please let me know, because where I've got the video set up here, I'm not able to see what's showing up on the screen. But this is an interlayer mixture that's going to be represented in the bar on the right, where I'm approaching over 1,300 and sometimes even over 1,400 in an ideal CT. I don't know if you can see this. I can take this mixture and I can bend it and I can twist it and I can turn it. You cannot do that with normal hot mix asphalt. I can with a little polymer modification in this one and with fiber, and that's what you're seeing on that orange bar. If I take the polymer out and just leave the polymer fiber, I get like a 650. So that gives you an idea of where we can go with taking a mixture and modify it. If I took all of that out, just this mixture alone with the high asphalt content would probably land in around the 300 range. But you can see where we can go by adding the different materials. So let's talk a little bit about, just to educate, and what Brett is challenging you with today is talk a little bit about the production. What is fiber? Let's talk about the production. What's it look like in the field? Some case studies, and the cost is another one that's mentioned in there. I do not have a slide on the cost, so I want to go ahead and get the elephant out of the room on that one instead of waiting to the end. I'll throw that one out to you right now. What I have seen as an engineer is where this has been bidding. Of course, on larger jobs, I've seen the numbers come in lower. Smaller jobs, they're higher because there's a setup cost. But typically, it can increase mixed cost about 10%, and that is a very rough number. It depends on what's bid to the contractor, what the contractor then bids to the agency or bids to the customer. It depends on the size of job, depends on the location, on and on. But that will give you an idea. And again, contact Surface Tech and contact Forta to get those specific details. There's a lot of stuff in here today that I'm going to be showing you that's talking about two products. One brand, there's two brands out there. One is Surface Tech, and another one is Forta, Fortify, and by Forta Corporation. And I am associated with Surface Tech. So what I show you is going to be very generic as I can for both of these products. And again, want to encourage you to reach out to both of these manufacturers. So what is Aramid fiber? Well, Aramid, or Aramid shortened, is a high-performance man-made polymer fiber that's been used in ballistic protection, bulletproof vest, if you want to think about it, heat cut protection, automotive industry. You think about the term Kevlar would make sense to you. One brand of the Aramid fiber is Kevlar. Think about where Kevlar is used today: ropes, cables, optical fiber, conveyor belts. I was talking with some of the guys that make Aramid fiber, and they said they're now making a para-Aramid paper. I don't know why we need para-Aramid paper, but I thought that was interesting. Maybe it's something they're going to take to the moon and write on up there. I don't know. But in asphalt, what we do is they make a fiber that's anywhere from 3/4 to 1.5 inches long. And these fibers are added usually like around 2 to 4 ounces, depending upon if it's a single dose or a double dose. You could do a dose and a half. But why even 2 ounces? Well, it was determined that that's sort of a sensible range to add them just to get started. So 2.1 ounces per ton, both manufacturers. My understanding is that's what's in both manufacturers' product, and we'll go into more detail on that in a moment. It's usually added at the wrap collar, at a drum mix plant. At a batch plant, you naturally put it right in. You put it right into the ag batch. These fibers, again, you're dealing with fibers that are it's crazy how many, 10 to 20 million in each ton of asphalt, or because just in a small bundle I'm dealing with about 5 to 10,000 fibers depending on what size I cut it, just in a small bundle. There's no change to the mix design, and there's no liquid binder. Let me say that again. No change to the mix design. I have put up to 10 times the fiber in mixes. I've been asked to validate it, and I have, with no change in the mix design. Other labs have done the same. This fiber is not cellulose fiber. It is not a poly fiber. This fiber is made to It is not a acrylic fiber. This fiber is not made to absorb asphalt. This fiber is not made to sponge the asphalt like you would see in an SMA to stop drain down. This fiber is made as a structural fiber and engineered. It's not a waste fiber, and it's cut to length, again, for the specific use of enhancing the mixture. Aramid, para-aramid, for short, is a fiber that's actually been, let me change something here. Para-aramid is a fiber that is actually stronger than steel. That's why it's used in the ballistics industry. And if you look on the chart over here, on the bottom is strain or movement, on the top is strength. And this helps you understand the fibers that you've seen before have been PET or cellulose fiber. And PET actually had really good reviews back in the day in the 90s when it was used, and it was going to stop cracking, and it did so many good things. It showed good on the Federal Highway ALF test facility where it was excellent in cracking resistance. SuperPave came out, so the fiber sort of went away. However, today you have aramid fiber that's a heat resistance fiber, that's not a waste fiber, that's cut again to length, that's very useful. I'm going to continue to say in 10 years, maybe sooner, this is going to be as common as what you see rebar in concrete, because the one thing that we miss in asphalt is we don't have a tensile reinforcement. We rely on the asphalt liquid itself to provide that, and which is a variable in itself. On the left, you see all these different properties of para-aramid. And on the right, you see the chart, and it gives you an idea of where it comes in. Now, the one that goes way up high is carbon fiber. Why aren't we using carbon fiber? Well, that's cool, but right now, using the aramid, the aramid's stronger than the asphalt, so we don't necessarily need to be entering into the carbon fiber world. Just using the aramid fiber, being heat resistant, aging resistant, and on, is incredible in itself. If you begin to look at it, you have these hair-like fibrils that begin to roughen, and that's what embeds or roots into the asphalt. That's been studied and proven. This gives you an idea, just a close-up of what the fiber begins to look like in the asphalt. Comparing it to polymer is another thing that's good to do. Now, first off, I love polymer modified asphalt. Those that know me, that I have a strong background with polymer modification where we do this. It has to be done in a terminal where it's sheared in or stirred in. It has to be reacted where the polymer will swell. And the polymer has done really well. It expands the performance grade. And on the right, you see it improves cracking. You're adding it at the terminal. It expands the PG. It improves adhesion to the binder to the aggregate. It improves mixture cohesion, holding it together. You do have to adjust it because there's an increased temperature that comes with using the polymer modification. And little change in the mix design. Sometimes you see a tenth or two just because of the volumetrics, because you're dealing with a more viscous liquid that doesn't absorb into the aggregate. Let's compare that now to the fiber reinforced asphalt. And a way to think about this is para-aramid is polymer, by the way. Para-aramid is just putting the polymer in as a fiber, but a fiber that does not melt, okay? A fiber that will stretch as it reinforces the mixture. So the fiber depends on the asphalt liquid to engage it, but is not dependent upon the compatibility. Like you hear some people talk about, well, I put Reob in, or I've got waxy this, or I've got, all these different things. Asphalt dependency is not, or asphalt type is not going to change how the fiber works in the mixture. But you do need asphalt to bond the fiber into the mixture. So a really dry mix, for instance, may not have as good a performance as a mixture that's at optimum asphalt content. You add it at the mix plant, not at the terminal. Comparing to polymer modified asphalt, you also expand your PG. Now, how did we figure that one out? Without doing the liquid testing, I can actually go on the mix side and began to run Hamburg and ideal CT, or I could run more advanced tests and understand equivalent on a mixture. I can get about 1 bump high and low, again about, and it's probably more like about 5 degrees on the low end and probably about 4 degrees on the high end, and where I'm seeing an improvement in rutting and cracking and rutting. It does improve the mixture by rooting into the mix. It improves the cohesion by holding the mixture together. It cannot make the asphalt bond to the aggregate, okay? But it can hold everything together, so it improves cohesion, not necessarily adhesion. There is no change in mix temperature, no change in production. Matter of fact, the guys won't even know it's there in the field unless you tell them. No change in the mix design volumetrics, and it is alkali. It is PPA resistant, as we have tested. So how do I bid, and then how do I build with Aramid fiber? Well, in the U.S., there's 2 U.S. suppliers, and I think what both, in talking to both, and again talking to more to Surface Tech, both would want you to know that give them notice. Don't call them up the 24 hours before and say that you got a job. It does take. They have to coordinate getting the equipment. They have to coordinate getting the material to you, and so on. But both Surface Tech and Fortify do supply the product. Fortify is the product on the right, and that is the one where they're using 2.1 ounces of Aramid plus 13.9 ounces of a plastic, and it's like a sheath. I actually have some of that here, and I'll pull that out and show you. This is what the Forta product looks like, and again, it's the better picture is there on the right versus what's in my hand. And you can reach out to those guys for samples. They'll send it to you in a bag. Same thing with the guys that with the guys that make the Ace XP with the Surface Tech. In your area in Michigan, that's going to be supplied through Site Supply. Again, a good client of mine. You're going to reach out to those guys, Kevin McLevain, Joe Dennis, and the folks up there who can help you with that. In that case, their product is 2.1 ounces of Aramid, as you see in the top left picture, bound with 1.3 ounces of Sasabit wax. Okay, so to give you an idea, I would put 5 of these sticks, maybe 6 sticks, in a sample in the laboratory. Now, I wouldn't actually mix it like that in the lab. I would put it in loose, but it gives you an idea how many of these go in. So in a ton of asphalt, you're looking at thousands or at least hundreds of these guys in a ton of asphalt. And when you look in a truckload, you're thousands of these going into a truckload. The Ace XP polymer in the top, you're taking, how is Aramid fiber made? Well, it's actually a liquid. They'll take the chemical product that comes out of the refining process. They'll hit it with an acid, turns it into a liquid, and then they'll pull it out of a machine and begin to spin a yarn with it. And that's how they make the yarn. That's how they weave the bulletproof vest and so on. Well, that yarn is in what we're using here. There's all different types. This one is about 8 microns. So this is about 1/10. Every one of these little fibers on here, again, holding it up close, you can begin to see the little fibers coming off. They're about 1/10 the size of a hair that's in your head. In this case, you take the Aramid fiber, you add it to the wax, and you get the product on the right, which is bound in a, looks like a Q-tip almost. Forta, again, the active ingredient, they're taking the same 2.1 ounces of the Aramid. They're going to wrap it in a what I call a sheath or a plastic, and in that one they're using usually about 13.9 ounces of the plastic, and then you're going to get the product on the right. Both products are designed so that when heated, the plastic or the wax goes away during the heating process and delivers the fiber into the mixture. Well, why can't I just take the fiber and put it in there? Well, it's because this fiber is so lightweight, it would blow away ever so quickly. So the moment it would hit the plant, it would end up in a bag house. And that's why you have to weight the product to get it into the plant. When bidding Aramid fiber, remember, contract the supply early. Understand what the spec's calling for. Is it 1 or a 2x dose? And we'll look at a spec here in a moment. What's the length of the fiber? The size of the project, days of production. If it's a larger project, you may want to buy a machine and work with the guys that supply these dosing machines to do that, or you may just want to rent. Do you need assistance, a technician to help run, or you want to self-certify this and get trained? Again, looking for a lead time of 1 to 2 weeks. Michigan, Department of Michigan, has a special provision for Aramid fibers that's being shown here on the screen. Again, this is really small text. So again, if you need that, I'm sure that could be sent to you, where it actually calls out the length, the diameter, the gravity, and so on. It talks about how it's put in during production and at the plant, drum or batch plant. It talks about sampling it and understanding all the way down. Of course, the favorite thing there is how do you measure and pay for it? And that's always a good question. How do you know the fibers even in the mixture? Well, we're going to talk about that in just a moment. When I go to design with Aramid fiber, let me show you how to get it into the mixture first, and then we'll look at it in the field. If I go into the laboratory, keep in mind that you're going to need a precision scale. You can't use something that just reads to 0.0 grams. You're going to have something that reads to 3 or 4 decimal places. There's going to be no change in the mix design. I said I've verified it up to a 4x dose. I've even done more than that. Follow the manufacturer's instructions, whether it is Fortify Corporation or Site Supply with Surface Tech. Check with those guys on getting the latest and how to introduce it into the mixture. It's always best just to sample at the plant, but if you have to do it in the lab, there are ways to do that. You're going to prepare the fiber and then just proceed as usual. So the goal of lab mixing is to disperse the fiber of what would be similar to dispersing it at a plant in about 30 seconds of mixing time. In the lab procedure, we're going to use a bucket mixer. You cannot use a wire whip mixer. A wire whip mixer will pick it all up. As one guy told me, he said, "Hey, I got it all in there, but I didn't see a difference in my laboratory testing." He walked me through the process, and he said, "Well, all the fiber ended up on the wire whip. So don't worry, I got it taken care of. I scraped off all the fiber. I threw it in the top of the pan so I know the fiber's in there." Sounds logical, but a bunch of fiber sprinkled on the top of a pan is not good, and it would be equivalent to sprinkling flour on a bunch of eggs and say, "I just made a cake." It doesn't work that way. That it has to be intermixed. So in this case, I'm going to be using 2.1 ounces of Aramid in my mixing process. Now, what's that mean? If I'm looking at it with just a pure Aramid, I'm looking at 0.00666%. Wrap your head around that, 0.00666%, a really small amount. Typical fiber, you may be looking at 0.3%, or 0.03 for some, okay? This is a really lightweight fiber, so it's 0.006%. Again, that's why you have to have a precision scale. When you're mixing and you put it in there, you do not want to end up with this. If I just put it in there and spin it around, I just made yarn, and that is not what I want to do. What I have to do is I've got to separate my fiber. And if doing this with the Surface Tech guys, they'll actually send you bagged fiber that's already pre-separated that's going to look more like what you see on the left. But even in the laboratory, we even break it down further than that to get it ready. So you're going to take the fiber and break it down into from the packaged into the really small fibers to get them ready for the mix design. I'm going to separate it, then I'm going to measure the amount that I have. I'm going to store it in a closed container. Why do that? Even a small sneeze or a little puff of air can blow the fibers out of that tin. So get you a small tin cup or a cup, put a bag or something over the top of it to keep the fibers in it. Again, an example is a 5,000 gram batch only needs 0.33 grams of the pure aramid. I'm not talking about the wax or the plastic. Just talking about the pure aramid, 0.33 grams. And on the right is an example of a precision scale where you have the glass, enclosed glass area.
Hey, Phil, got about
Yeah.
10 minutes or so, and then we'll open it up to questions. So just
Got it. Absolutely. That's what I need. Thank you very much for that. Yep. You're going to layer this into the aggregate, such as aggregate fiber. And again, there's directions and videos out there that they can send you to explain how to do it. You're going to mix it as usual, and then you're going to just proceed as usual with conditioning, aging, compacting. And you're going to get something that looks like what you see here. You'll see the fibers that become very obvious that they're mixed in. And that's what you're wanting to see. Now, in the field, when you're paving, you won't see this unless you're luting. And with the lute or the scraper or the shovel, you'll see the fibers on the end. And that's how you know the fiber's in there. Otherwise, you don't even notice it's there. If I'm putting it in at a plant, again, at a drum plant, you would feed it into the wrap collar batch plant. It's going to go in to the weigh hopper or pug mill. Again, talk to your individual manufacturers for details. This is an example of Surface Tech's mobile system or their smaller system that they have, where they can use a small line vac system, weigh out the fiber and put it in what they call hand dosing. That's again for a really small job. That is all put into a kit that you see here, what they call a line vac kit. If you look at a larger production, you have a trailer that could be pulled in with a large machine, a large automated dosing machine. You see here on the right how you would take this, and it even kicks out a report at the end of the day as it regulates the fiber that goes in along with the speed of the plant to make sure you have a continuous fed fiber that's going into the plant. There is a system that's out there, and I don't have the picture in here, but I do want to mention. Go and check out Forta Fibers system. They also have an automated dosing system that will blow the fibers into the plant. And again, they can measure that and provide, my understanding is, reports at the end of the day on the amount that goes in. If I look at it in the field, again, it's business as usual. I can look on the front of the paver and I can see the fibers that's within the asphalt. If I look into the field, I'm seeing regular asphalt. These are two projects that were fiber, so you don't see fiber sticking up everywhere. Again, it just disappears into the mixture. A couple of case studies, and Brett, I'm going to go through these rather quickly. But the point here is just showing you some cracking data. This one, it was done up in Indiana, in Plainfield, Indiana. And this is one where your conventional mix that you see that where the cracks are is placed as compared to the fiber mix. And that's not saying our conventional mixes are bad, okay? Our conventional mixes are conventional mixes. It's just saying that when I put the fiber reinforcement in, I'm enhancing that performance. And it makes sense, right? Like rebar helps with cracking in concrete. Aramid fiber is going to help with cracking in asphalt. I look at other ones, and you can begin to see here again the fiber lanes with the control lanes. Well, that's all good and fine, and I can show you that all day long, because you can say, well, maybe there's concrete under one, and you got to know what's underneath the pavement. Bottom line, the proof comes into when you look at it over and over and over, and not just 1 year, and then you begin to compile it, and you understand that my fiber reinforced on this one, after 4 years, has only 78 linear feet of cracking as compared to my conventional mix that has 954 feet of cracking. The only difference between the 78 and 954 is that fiber was added to this mixture. Same asphalt content, same week of placement, same area, same mix design, on and on. This was also done in an iFit test. And in this one, and I'm going to point you, there was a couple of different things that happened here on the air voids on this one. So ignore the middle one where the air voids got out of control. But just looking here, you have an 8.61 iFit value compared to a 12.41. 12.41 That if you were putting in an ideal CT, this would be like an 86 compared to a 124. In an iFit, it's 8 compared to a 12. And the 12 says it should do better in the field. And it did, as you saw. If I look into Kentucky, there was a project in Kentucky on Dixie Highway, US 31, where they did several different cracking treatments, but just looking at what the fiber did, this was a 4-lane highway as it feeds into the arterials there into, or a primary arterial that feeds into the interstate there in Kentucky. And this is over in the Louisville area. In this one, you see the same thing where you have the cracks beginning to start. This was paved about the same time here as they paved the eastbound, and then they paved the westbound. As you begin to look at this one, you can see the areas where the fiber was, there's less cracking. Now, are there cracks in the, and by the way, there's concrete underneath this. It's about 4 inches, I believe. There's absolutely concrete underneath this. So this was done a little bit more of as a reflective cracking experiment. Are those cracks going to come through? Sure, they will. But let's look what they're doing over time. The conventional mix with the like a 7622 has 941 feet of cracking compared to almost 600 feet of cracking. 43% fewer cracks. That's a 7-year comparison. And guys, to Site Supply, thank you for continuing to go out and get this data. This is the type of data that engineers like myself need, not just to convince me, but to be able to put these projects out and have confidence and knowing what I'm getting into, and it's proving out what we have seen in the lab for the past 5-6 years. Love's Truck Stop. Love Truck Stops call out fiber now on every job that goes out into the U.S. And why is that? Because they continue to see performance, not just after 1 year, not just after 2 years, but after 7 years, they're continuing to be happy with the performance that they're seeing. This one is in Kentucky. This was the first one that was done by Love's. And just to give you an idea of what a Love's Truck Stop typically looks like, this is a whole different base, whole different area, but it's not uncommon to see something like on the right, where you get a lot of cracking as compared to the left where it looks better. So what's that look like? Well, if you go and pull the mixture, this is one that was done from Love's up in Obet, an Ohio project. This one is an ideal CT where I'm looking and I'm going to compare. And again, you see an improvement in ideal CT as compared to the 7022 with modification. I see Hamburg values that look good. Again, prove it in the lab, prove it in the field. With that, Brett, I could go on with data and have fun with that all day long. Bottom line, I'm impressed with fiber. I think you're going to see it become more and more common. Yes, it helps with modulus. Yes, it helps with with rutting. The big news is helping with cracking, and you'll see results quickly. With that, I want to encourage everyone to become an AAPT member. If you're not familiar with that organization, just ask me, and I'm glad to tell you more about it. There's my contact information. I'll leave that up, and Brett, I'm going to turn it over to you. And you want me to move on to the next slide for the closing slides?
It doesn't matter much. I think the next slide is probably a duplicate of this information anyhow. So
okay.
Again, thanks, Phil, for coming on and educating us a bit on Aramid fibers. Sounds like you could talk for days on this. So I think we just scratched the surface, but it was very helpful. Reminder, if you have any questions, feel free to type them in the chat. I do have a couple questions here. Actually, there's a question right there. So Allison from MDOT has a question for you. If you have any statistics on cracking comparisons longer than 7 years, question mark, over 12 years, question mark.
Boy, that's a good one. I wish. I've only been working with it since 2015. I believe Aramid fibers were introduced sometime in the 90s. I do not have data that goes back that long. The trends I'm seeing are this. It's polymer. Okay, we know documented proof that polymers extend pavement life 3 to 5 years. I think you're going to get that and more with Aramid fiber, but I do not have anything past what I'm showing you. I've gone out, I've done FWD data where we've looked at structural improvements of 20%. Do I have anything at 12 years? I do not. However, talk to me in about 5 years and I will.
You're not aware of any research projects out there? I know there's a few from way back, like Texas, I think a couple.
Yeah, Texas may have some. You may check with Arizona State. They may have some going back. Most of the documentation that's going down right now that I've seen. Well, let me back up. The fibers in general of using even the cheaper fiber, the PET and PAN fibers, were researched again by Federal Highways at ALF, and those go back into the 90s. Indiana was doing the PET and PAN fibers in the 90s with great success. The issue they had was how to introduce it at the plant. Okay, so that's where these guys have met that challenge. So are there pavements that's working that's out there? Yeah, how well they're documented. I've got a few papers on that, but I don't have anything recent on this.
All right, thank you for that. There's another question. So asphalt being the largest by volume recycled, or by weight, sorry, recycled product in the United States, how does using Aramid fibers impact or not impact recycling mix?
Oh, always a good question. I would love to tell you that when you recycle it and use it, that I've got documented proof that the Aramid fiber continues to reinforce the mixture, and it should. Okay. I don't have that, but when you recycle it, you're going to recycle it like normal. It's not going to hinder recycling. You won't know it's there. When you heat it back up, again, the fibers aren't rotting. They're not aging. They're not getting brittle. When you heat it back up and put it back down, the fibers should still be in it. So if I was a contractor, I would want to separate my fiber reinforced wrap pile so I would value it more.
Okay. Just thinking about like on the lab side of things, for those states that run extractions, are there any special modifications to the extraction process that needs to happen when you're running a mix that has fibers in it?
No, I've even got an auto extractor. I use an auto analyzer brand from Infratest, and I've put it in that cage, and I'll spin it out. Sometimes you'll get fibers that can get on the cage, and you just have to pull them out. It will end up in the cup, or if you're doing with the plug device, you'll actually end up in the bowl, and you'll see the fibers. Unfortunately, when you extract it, you're spinning it, right? And in that one, your fibers will conglomerate together. That's not what they're doing in the mixture. However, in the extraction process, it makes it really easy to see where the fibers are. And then when you run the mixture over your nest of sieves and you wash it, or when you wash it over 200, you'll see that the fiber catch on top of that. And you can measure the amount of fiber that's in. It's hard to get the dust off of it, but you can see if the fiber's in it through the extraction. It does not hinder the extraction. And again, this stuff right here will not change the weight. I mean, again, it's really lightweight, and it won't change the weight of what you're doing in your mixture.
Okay. I guess
negligible.
One final question would be you showed a picture of the mix in the paver, and you could see the little fibers sticking out of the mix. How does an agency, an owner, assure that they're getting the correct quantity in their mixture?
You count them. No. There is a report that's put out. Surface Techs with Site Supply puts out a report. I think you could do it every 15 seconds, but I think they're summarizing like every minute the plant's running, and it will tell you the ounces that's going in there. Again, you can always check the calibration at the plant with it. But you can measure it. You can get the report that's going in. So you push the QC onto the manufacturer. Forta should be able to produce the same thing with the end of day report. so you can see the continuous feeding that's going into it. If I'm checking it on the mix side, I can pull a mixture out. I can look at it in the laboratory. I can see it's in there. I can run an ideal CT and see the difference where it's in there. I could always do an extraction and make sure it's in there. So different ways to do that. Now,
All right.
I guess a comment I'd make, I haven't really done this. If you do a burn off, my bet is that the fibers will blow through the exhaust. So the burn off probably wouldn't pick up the fiber.
Okay. All right, but again, the weight's so negligible, it won't.
That's right.
Impact
Yeah.
your
Yeah.
results.
You can't measure fiber with the burn off, but it's not going to hurt your asphalt content.
Sure. Okay. Well, again, I thank you very much. And for those of you still on the line here, again, this session was recorded. So if you want to watch it again, share it with your friends and family or whatever you'd like to do with it, feel free to reach out. If you have any other questions, Phil's contact was there. You can also reach out to us here at the association. Encourage you to stay tuned for future webinar offerings, as well as our in-person stuff if you're here in the state of Michigan or in a bordering state. We'll be having our annual conference at the end of February 2023, so we hope you can make it there for that. And Phil, I'm very surprised that you baited Tim and he didn't even chime in with a question. So I'm disappointed in our federal highway representative on the call today. So.
Oh, well, and I mentioned his two favorite products with the interlayer and the SMA. So again, thank you all. And Brett, I hope to join you at the association meeting. Thank you for allowing me, a Kentucky boy, to present for you guys in Michigan. And hope everybody has a good holiday coming up.
All right. Thank you very much. Thank you all. Have a great day.